Hello everyone, my name is Tyler, and this week we'll be going over the collision tab in the Unity particle system and what it does. The starting kind of particle system and starting scene actually is going to be different than what we usually use, so I'll explain what those are before we actually go on to the collision tab. So the starting particle system for this week is kind of just a simple box emitter that's emitting more particles than the default, and it also doesn't have any starting speed and instead has just gravity applied to the particles. I also made the size smaller so we can kind of see them more clearly without them overlapping with each other. The other big difference is that I have terrain, just so we can see what collision looks like for non-even surfaces. If you don't know how to make terrain, it's actually pretty simple. You can just go to Game Object, Create Other, and then Terrain, and then you can just click on this tool over here, and then just left click kind of anywhere on the terrain to make hills, and that's good enough for our purposes. If you want more detailed videos, Unity has a bunch of pretty cool ones on their site that will actually help you out a lot when you're doing that stuff. So with that all explained, let's get started. Collision in Unity can kind of be based upon two different things, either planar collision or world collision. Planar collision is basically just having the particles collide with a flat plane and then determining where that flat plane is located. World collision is more interesting, as we'll see later on, as it uses the collision boxes of different objects in your scene and actually uses those collision boxes to have the particles collide off of and bounce off of and stuff. So that's pretty interesting. But we'll just do planar collision for now, so you just set it to planes. In this box right here, you just kind of specify what objects you want your particles to be colliding with. So since we have a nice little terrain set up, let's do that. And immediately you can see the particles kind of just bouncing off the terrain and then kind of going up and down as they're bouncing. And then you also see this grid pop up. This grid is the visual representation of the plane that you're colliding with. You can make that plane either bigger or smaller by modifying this variable right here. You can also, this dampen variable, actually, let's go over visualization first. If you don't like the grid, you can also just have it be a solid so you can kind of see it more clearly. If you have a lot of things going on in your scene, that's pretty handy. But we can just stick with the grid for now because it's pretty simple to look at, and it provides a nice contrast. So the first variable that you can kind of mess with in collision that actually affects how your particles collide is dampen. And what this does is it will slow down a particle based on a percentage of its speed every time the particle collides with that object. All of these variables that you're messing with are kind of based off of percentages instead of actual real world values. So just keep that in mind. If you have anything greater than 1, then Unity will kind of just go a little crazy. So let's just put in a nice safe value of 0.5. So as you can see here, the first time the particles are bouncing, they're losing about half their speed. Then when they bounce again, they're kind of basically lost almost all of their speed, so they're kind of just staying on the ground there. So let's put that back to 0. And now our particles are bouncing like crazy again. And what determines that is this bounce variable, and this bounce variable determines basically how fast the particles are going to be launched after they hit your collidable object. So if you have that at 1, they're basically little bouncy balls, and they'll just basically retain almost all of their energy after each bounce. And if you set that to a lower value like 0.2, they'll lose most of their energy. If you put it to 0.8, they'll only lose some of their energy. So that's pretty handy. Let's put that back to 1 actually. Lifetime loss is the particles will kind of lose some of their lifetime each time they collide with your object. So let's put that at 0.5. And as you can see, there's much less particles in the scene, even after they're bouncing, so they're losing about half of their lifetime after each bounce, so there's much less particles sticking around. Let's put that back to 0. You can also set a minimum kill speed, and whenever the particle reaches this speed, it will the Unity will basically remove that particle from your scene. So if we set the bounce to 0.8, and then we set the minimum kill speed to 2 or something, maybe 3, you can kind of, it's a little difficult to see, but after each bounce the particle is losing a little bit of its speed, and the particles with speed 3 or less are actually being immediately killed off. So that's kind of one of the subtle things that you can do to help your game. The next thing is particle radius. This kind of lets you define the size of your particle when Unity is using it for collision. Usually Unity just has particles are basically like points, and here you can kind of define them as actually circles, so you can define how large their radius is for Unity. The last thing that you can do is send a collision message, and this is for more of the kind of code side of things, where if you want to know when your particles are colliding with an object, so you can do something special, like have a burn mark on the wall that the particle collided with or something, you can do that by checking the collision messages that Unity is sending. So that's pretty cool. So now let's move on to the actual world collider, because flat objects are interesting and all, but they're not as cool as hills. So let's go over here and then kind of demonstrate like what the world's collision does. So as you can see right now, the particles aren't colliding with the terrain, even though we have it set on the plane and we have the terrain as our object. That's because they're colliding with the actual plane all the way at the bottom of the terrain where it's defined. So that isn't exactly what we want. We want the particles to be colliding with the world objects. And right now you can see that Unity is using the actual terrain's collision boxes in order to determine where the particles should collide. And you can see that the particles are kind of just rolling down this hill after they're colliding with the terrain. So that's pretty nifty. So this is a new feature that they added in Unity 4. And it's really handy because as long as your object has definable collision, you can just set the collision to world, and the particles will be like, oh, I can collide with this object, instead of, oh, I need to define the plane and then figure out where the plane is and then I can collide with it. No, you can just use the defined collision of the object to have your particles collide with it. And then you can use all these variables as usual to kind of define how you want those collisions to occur and what happens after they occur, as usual. So that's about it for this week. Next week we'll be going over sub-emitters. So as usual, if you have any questions, leave them in comments, and thanks for watching. I'll see you next week.